Hello and welcome to the very first project of our SysD Python project masterclass. I'm thrilled that you are here and I want to congratulate you on taking this exciting step. Today we're going to build a digital clock that runs on your desktop, a live ticking clock just like the one you might see on your phone's home screen. We'll be using Python's built-in tkinter library, which is the standard way to create graphical user interfaces, and the time module to grab the current system time. If you have never built a GUI before, don't worry. I'll guide you through every single line of code, explaining what it does and why we are writing it that way. By the end, you'll understand how to create a window, put a label inside it, update that label every second, and handle the event loop that keeps the program running. This might seem simple, but it introduces fundamental concepts: window management, visual styling, and schedule function calls that you'll use in almost every future project. So let's get started and have some fun making our first Python application come live on a screen. Thank you. Now let's look at the code line by line. We start by importing tkinter as tk for convenience, and from the time module we import strftime, strftime, which lets us format dates and times. Next, root equal tk.tk creates the main application window. Think of it as the blank canvas where everything will be drawn. We then set the title to digital clock using root.title and define the window size with a root.geometry 400 to 200 for the pixels wide by 200 height. I have disabled resizing with resizable false to keep the layout neat. After that, we create a label widget called clock label and place it in the window. The label uses a big, bold Arial font, a black background, and a cyan foreground color. The pack expand through call centers that center the label within the window. The core logic lives in update time. Inside this function, we call strftime %h, %m, %s to get the current hour, minute, and the second of the string. That string is passed to clocklabel.config to refresh what's displayed. Then the crucial time. Clock label after 1000 update time tells tkinter wait 1000 milliseconds, which is 1 second, and then call this same function again. This creates a loop without freezing the interface. Finally, we call update time once to start the cycle, and a root.mailLoop enters the event loop, keeping the window open and responsive until you see it. Excellent job getting the clock running. Now let me share some pro tips that will help you deepen your understanding and avoid common pitfalls. First, notice that we use .after instead of time.sleep. That's absolutely critical. If you use a sleep function, the entire GUI becomes unresponsive because tkinter can't process any other events. Buttons wouldn't click, the window wouldn't even redraw. Always use .after for timed updates in tkinter. Next, play with the font. You can change Arial to Carrier for a monospaced digital looking clock, or even use a custom font if you have installed one. The color combination of cyan on black is very popular, but I encourage you to experiment with hex values. Maybe hashtag FFD700 for gold text on hashtag 2F for F4F for a cool slate background. Another professional touch is to make the window resizable and then use pack extend to fill both so the clock scales when you drag the window corners. If you want a 12-hour clock instead of 24-hour, just swap the format string to person I, person M, person S, person P. The person I gives hours 01, 12, and person P adds AM/PM. Also think about extending this project. You could add a second label showing the date or even a small button to toggle between time zones. These small additions turn a basic script into a polished, real-world tool. And remember, anytime you close the window, tkinter's main loop stops cleanly. But for more complex apps, you might attach a custom close handler to save user preferences. Next exercise. Now it's your turn to take this project to the next level. I've designed an exercise that will really cement your understanding. Your challenge is to customize the clock in 3 ways. First, change the time display from 24-hour format to 12-hour format with AM or PM. This is a simple format string swap, but make sure you test it at different times to see 12-hour PM versus 12 AM. Second, you need to add the current date below the time. Format a log Monday, 10 July 2026. You can either create a second label or combine both time and date in a single label using a new line character /n. Third, and this is the most creative part, you'll change the background color of the label based on the hour of the day. For example, use a soft morning tone for hours 6 to 11, a bright afternoon color to 12 to 5, and evening shade for 6 to 9, and a dark night color after that. To do this, extract the current hour as an integer with int strf time %, and then write simple if-elif conditions. This exercise will teach you how to manipulate strings, combine multiple pieces of information, and dynamically alter widget properties. Give it your best shot, pause the video, and when you're ready, come back to compare your solution with mine.